The F-35B Lightning II is one of the most advanced fighter jets ever created, a true symbol of modern air power and cutting-edge engineering. Designed by Lockheed Martin, the F-35B represents the short takeoff and vertical landing variant of the Joint Strike Fighter program, specifically tailored for the U.S. Marine Corps and allied forces that operate from aircraft carriers and amphibious assault ships. It's not just another stealth jet. It's a leap forward in versatility, technology, and combat effectiveness that completely redefines what a fifth-generation fighter can do on land, at sea, or in the skies. When the F-35B takes off, the first thing that captures attention is its unique ability to launch from extremely short runways, or even from small decks where traditional jets could never operate. This is made possible by its revolutionary lift fan system, which was co-developed by Rolls. In traditional fighter jets, powerful afterburners are used for takeoff. But the F-35B introduces a complex yet brilliant system that combines a shaft-driven lift fan at the front with a rotating rear exhaust nozzle. Together, these mechanisms allow the aircraft to hover, take off from short distances, and land vertically like a helicopter. This single capability gives the F-35B unmatched operational flexibility. It can operate from forward-deployed bases, amphibious ships, or even improvised runways, delivering combat power where it's needed most. The aircraft's engine, the Pratt & Whitney F-135, is a marvel in itself, capable of generating more than 40,000 pounds of thrust. It is one of the most powerful jet engines ever installed in a fighter. The engine's design allows the F-35B to transition smoothly between conventional flight and vertical flight modes with precision and stability. When you watch the F-35B take off, you can see this engineering mastery in action. The rear nozzle pivots downward, the lift fan doors open, and the jet rises almost effortlessly before tilting forward into flight. It's an awe-inspiring demonstration of human ingenuity and control over aerodynamic forces that once seemed impossible. Beyond its takeoff and landing prowess, the F-35B is also a stealth fighter through and through. Its airframe is built with radar-absorbent materials and sleek, angular surfaces that scatter radar waves, drastically reducing its radar cross-section. This means the jet can approach enemy airspace with minimal detection, giving it a tactical advantage in both offensive and defensive operations. The aircraft's internal weapons bays ensure that its radar signature remains low even when it's armed. Unlike older jets that have to carry external weapons that compromise stealth, the cockpit of the F-35B is equally revolutionary. Instead of a traditional array of analog gauges and switches, pilots are greeted with a panoramic touchscreen display that integrates all mission-critical information into one interface. The helmet-mounted display system, known as the HMDS, is perhaps the most advanced in the world. It allows pilots to literally see through the aircraft by projecting live video from cameras mounted around the airframe directly onto the visor. This 360-degree situational awareness transforms how a pilot perceives the battle space, offering a decisive edge in complex missions. Every movement of the pilot's head corresponds to a real-time change in perspective, whether it is tracking targets below, scanning for threats, or monitoring wingmen during formation flight. Performance-wise, the F-35B is designed to dominate multiple combat roles: air superiority, ground attack, intelligence gathering, and electronic warfare. With a top speed of approximately Mach 1.6 and a combat radius of over 830 kilometers, it can strike deep behind enemy lines while staying agile enough to dogfight with advanced enemy aircraft. Its advanced sensor suite fuses data from multiple sources: radar, infrared, electronic support measures, and more, to give pilots a unified, real-time picture of the battlefield. This level of data fusion reduces workload, improves decision-making, and allows the pilot to focus entirely on mission execution rather than juggling multiple inputs. Another remarkable feature is its sensor fusion capability. The brain of the aircraft, the Distributed Aperture System DAS, and the Active Electronically Scanned Array radar work together seamlessly to detect, identify, and track targets across vast distances. The aircraft not only identifies threats, but also shares that information instantly with other units through its advanced communications network. This makes the F-35B not just a fighter, but a flying data hub that can coordinate attacks, warn allies, and even control drones in future battlefield scenarios. In terms of weapons, the F-35B is built for precision. It can carry a wide variety of weapons in its internal base, including AIM-120 AMRAAM missiles, laser-guided bombs, and the future generation of hypersonic weapons. When stealth is not required, the aircraft can be equipped with external pylons to carry additional ordnance, dramatically increasing its payload. Its internal GAU-22A 25mm cannon provides short-range strike capability, ideal for close air support missions that Marines often depend on. What truly sets the F-35B apart from any aircraft before it is how it integrates into a network-centric warfare system. The jet is not operating in isolation. It's part of a digital ecosystem that includes ground forces, ships, satellites, and other aircraft. The F-35B's data link systems allow it to share sensor data, target information, and situational awareness across the entire battle network, effectively multiplying the effectiveness of all allied forces involved. It can detect threats long before they become visible and pass that information to other platforms, creating a seamless picture of the operational environment. When it comes to maintenance and sustainability, the F-35B employs a next-generation system called ALIS Autonomic Logistics Information System, now transitioning to ODIN Operational Data Integrated Network. This advanced logistics platform monitors the aircraft's performance, diagnoses issues, and predicts maintenance needs before they become problems. This predictive maintenance capability keeps readiness rates high and ensures that each jet can spend more time in the air and less time grounded for repairs. Design-wise, the F-35B looks both sleek and muscular, with its signature blended wing-body design, inward-canted vertical stabilizers, and large single-engine exhaust. Its overall aesthetic is shaped not just for stealth, but also for aerodynamic efficiency. The airframe's composite materials reduce weight while increasing durability, and the jet's low observable coating plays a critical role in maintaining its radar invisibility. Every line, edge, and panel is engineered with precision to ensure minimal radar reflection and maximum structural integrity. Pilots who fly the F-35B often describe it as intuitive and intelligent, a fighter that feels more like an extension of themselves than a machine. Its flight control system uses advanced fly-by-wire technology, constantly making micro-adjustments to maintain perfect balance and stability, even during the most complex maneuvers. This makes vertical takeoff and landing sequences appear smooth and controlled, despite the immense power involved. Watching it transition from hover to forward flight is like watching a ballet of technology, a precise synchronization of thrust, lift, and control surfaces that looks effortless but represents decades of research and engineering refinement. The F-35B stealth and agility make it ideal for first day of war operations, missions that require entering heavily defended airspace, taking out radar installations, and paving the way for other aircraft. It can operate independently or alongside other aircraft in a joint force. Its ability to provide real-time intelligence and situational awareness to both air and ground units makes it a force multiplier. In a modern battlefield, where speed, data, and precision define success, the F-35B's ability to sense, process, and act faster than its adversaries is a game-changer. Even its exhaust system, a key point of vulnerability in most jets, has been designed for stealth. The F-35B's nozzle can rotate 90 degrees to enable vertical thrust, but it's also crafted to minimize infrared emissions, reducing the aircraft's heat signature and making it harder to detect with heat-seeking missiles. Combined with advanced countermeasure systems that automatically deploy decoys or jam enemy radar, the jet ensures the highest levels of survivability in contested environments. Another underrated aspect of the F-35B's design is its compatibility with naval operations. Traditional fighter jets required catapults and arresting gear to launch and land on carriers. But the F-35B can operate from smaller amphibious assault ships like the USS Wasp or HMS Queen Elizabeth without those systems. This means countries with smaller navies can now field a fifth-generation fighter capability without investing in massive aircraft carriers. It has fundamentally changed the balance of power at sea by making advanced air power accessible to a wider range of nations. The versatility of the F-35B extends beyond combat. It can conduct intelligence, surveillance, and reconnaissance ISR missions with equal effectiveness, using its sensors to map out threats, gather electronic signatures, and track enemy movements in real time. Its advanced electronic warfare systems can jam enemy communications, conserve radar, and protect friendly assets. It's essentially a flying command center capable of both striking and guiding operations simultaneously. In training environments, pilots quickly realize that flying the F-35B is less about raw piloting skill and more about managing information. The jet's artificial intelligence-driven systems handle much of the technical flying, freeing the pilot to think strategically. This human-machine partnership is at the core of the F-35 program's philosophy, combining human intuition with machine precision. When viewed from the outside, especially during a vertical takeoff or landing, the F-35B looks like something straight out of science fiction. The roar of the engine, the downward blast of power, and the smooth, controlled descent are unlike anything seen in earlier generations of aircraft. Every movement feels deliberate, calculated, and perfectly synchronized. It's not just a demonstration of power. It's a showcase of balance between brute force and refined engineering. Countries like the United Kingdom, Italy, and Japan have already integrated the F-35B into their air and naval fleets, allowing them to project fifth-generation capabilities from virtually anywhere in the world. This global adaptability, combined with interoperability between allied forces, makes the F-35B a cornerstone of modern defense strategy. It ensures that allied nations can operate together seamlessly, sharing data and coordinating missions across air, land, and sea. The F-35B also plays a critical role in future warfare concepts such as multi-domain operations, where air, sea, land, cyber, and space elements are integrated into a single, cohesive battle plan. The aircraft's sensors and communication systems make it an ideal platform for such operations, ensuring it remains relevant for decades to come. Each takeoff of the F-35B symbolizes more than just the power of technology. It represents a new era of flexibility, survivability, and precision in air combat. Watching the jet lift vertically and accelerate into the sky is witnessing the culmination of decades of innovation, a perfect fusion of engineering brilliance and tactical vision. The F-35B isn't just designed to fight wars. It's built to redefine them, providing unmatched capabilities to forces that value mobility, adaptability, and technological superiority.